Assalamualaikum, my name is Muhammad Amir Ashraf. Okay, today I will present about my project, which is development of watering pump system to circulate water for fodder using NodeMCU. Okay, introduction. Forage is the primary source of nutrition for ruminant, and it is used to boost productivity by addressing basic demands like reproduction and production. As a result, methods and technologies to increase fodder supply were needed, such as the soilless farming system, which produces continuously regardless of the season and can be employed without requiring a large area. The soilless farming concept uses cereal plants to produce hydroponic feed with a quick harvest period. Hydroponic is a term used in agriculture to describe plant without the use of soil and instead using a solution of necessary nutrients that dissolve in water. Hydroponic fodder fed to small and large ruminants lowers the cost of producing feed crops while minimizing the waste. Okay, the problem statement. The watering system for fodder in this project is used to enhance crop watering efficiency and make it easy for the user to control the crop's water schedule. By referring to the conventional method, farmer or livestock breeders usually having difficulty monitoring the water cycle of their feeding crops. A farmer needs to ensure that the crops he grows must always have a sufficient amount of water and the correct time of the day. Crop watering efficiency usually affects the growth of a particular crop. Therefore, the watering the crops efficiently is crucial to ensure the healthiness of the crops. Research objective. First one, to improve water monitoring system by using NodeMCU. Next, to enhance water recirculation system quality and reduce water consumption. Scope of research: designing the fodder system by considering all factors including the dimension of fodder, the amount of grass produced by the fodder, and the time of the grass growth. Estimation of water volume and time is taken for the water to circulate an entire fodder system. Choosing the suitable pump to circulate the water based on usage needed. Selection of microcontroller component that is required by the system. Designing an automatic water recirculation for the fodder system. Observation and analysis on the grass growth and time taken for the water flow. Next, introduction of fodder. Plant cultivated for animal are known as fodder crops. Fodder crops are divided into two categories, which is temporary and permanent. Permanent fodder crops are land that has been used for herbaceous forest crops for at least 5 years, whether cultivated or growing wild. A fodder system can feed a vast variety of livestock for milk and meat production. If there is a drought, a fodder system will provide a small amount of forage for livestock. Fodder may produce a high quality feed for less money than traditional method. Okay, next we explain about wheatgrass. Wheatgrass was a worthwhile because of its enhanced growth rate, which result in many harvesting from a single crop input as well as its nutritional quality. It is highly digestible and nutritive with enhanced protein, starch and sugar as the main benefit of the sprouted fodder overfeeding grain. Irrigation system. Irrigation is a method of providing plants with water in order for them to meet their needs for a number of important resources. There is a few types of irrigation method. The first one is sprinkler system. Next, mist and fog system, and the last one is boom system. Irrigation controlled by NodeMCU. The goal of this study is to create a low-cost hydroponic system that can keep the water level in the growth rate constant using a simple microcontroller control mechanism. Unlike a traditional hydroponic system, the pump does not need to run continually. In comparison to other traditional ways in the irrigation sector, the technique addressed in this study can be considered an appropriate strategy in the irrigation field because it saves time, money and manpower. Methodology. The goal of this project is to use a NodeMCU to maximize the use of water in the irrigation system process as well as to construct an ecologically friendly feed system. The project required to use a NodeMCU, a soil moisture sensor and humidity sensor and a water pump. Okay, this is the flowchart of the project. First we start, then we identify the problem, After that, we developing research objective. Next, we find the literature work that relate to the project. Next, we need to determine the parameter. After that, we will design an irrigation system. After that, we will test and analysis. If the test and analysis not meet the specification, we will try to design on another concept again. Okay, and if the test and analysis is proof, we move to the discussion, documentation and report writing, and then that's all for the project. Okay, selection of controller. For the irrigation system, the selection of controller is crucial to ensure the working performance of the system is at its best. An embedded system for program control of a water system is included in this suggested work. This project uses a remote sensor system to identify a water system design in real time. This design maintains a strategic distance from water wastage while providing a uniform and required level of water for the automation of water system framework using IoT. When the moisture level in the soil drops below a preset limit, the pump is automatically turned on by the system, and then when the water level returns to the normal, the pump will automatically turn off the detected parameter as well. The parameter current condition will be displayed on the Blink application. Okay, this is the block diagram of working principle, NodeMCU working principle. Okay, moisture and humidity sensor will send a signal to the NodeMCU, and then NodeMCU will send another signal, analog signal, to the water pump and growing light. Then the user can monitor the process by using Blink apps. Sensor. There is two sensors we use in this project. First one, soil moisture sensor, measure the volumetric water content in soil. The sensor was utilized to detect the presence of moisture in the hydroponic plant in this project. The sensor will send a signal to NodeMCU to switch on the water pump when it detects less moisture in the planting tray. The humidity sensor is the other sensor used in this experiment. To reduce the frequency of watering, a temperature and humidity sensor is required. That is, as the weather cold, less water is required, and opposite case, more water is required. Okay, on this project we will using the Blink apps. Blink is IoT platform that allows users to build their own application to control and receive data from their project over the internet. When the NodeMCU have the internet connection, it will display the data on the Blink software, which allow users to track their hydroponic current condition. Okay, this is the watering system layout. The first, water will pump from the water reservoir and will flow through the frame, as you can see on the diagram. Okay, until the water reach on the top level of the frame, it will automatically recirculate into the reservoir tank due to the slope that we have there. So the water that drop from the sprinkler will drop to the tray and continue into the water reservoir. Result and discussion. The result of testing a prototype of the watering pump system to circulate water for Fodder using NodeMCU, as well as a discussion of the result, will be discussed in detail in this chapter. The analysis result, which is the plant growth rate based on observation and multiple measurement, water circulation, sprinkler spread, and water consumption, are all included in this chapter. Germinating process. First, the plant must go through the germination technique, in which seed is soaked with water for roughly 4 to 12 hours, and water is sprayed on the seed twice a day till the radicle is seen before shifting the seed into the developing tray. For this procedure, two sets of germination process has been conducted, which is 4 hours and 12-hour immerse process, to compare the different. Okay, this is the two tray of seed that soak for two different time. Okay, the first one is soaked for 4 hours and the second one is for 2 hours. Both of these seed is taken on the second days of the germination. As you can see, the seed that soaked for 4 hours germinate slowly, then the seed that soaked for 12 hours. Okay, next, analysis of wheatgrass growing rate. Okay, this is the table of analysis wheatgrass growing rate. I've taken 3 set of day. First is on the day 6, second day 8 and day 10. As a result, for the day 6, the height is 8.3 cm. For the day 8 is 9.8 cm, and the 10th day is 14.4 cm. Okay, also we can see the difference of humidity and moisture of the each day. So the total plant growth rate for the day 6 is 0.5 cm per day, for day 8 is 0.5 cm per day, and day 10 is 1.53 cm per day. Okay, sprinkler system. A sprinkler irrigation system use a pump to apply water under high pressure. It uses a small diameter nozzle in the pipe to discharge water in a rain-like pattern. There is 2 types of sprinkler we use in this analysis. Okay, the first one is the fixed 360 sprinkler. The second one is multi-stream sprinkler. The working pressure for the both sprinkler is same, which is 1.5 until 3 bar of pressure, but the nozzle diameter is for fixed 360 sprinkler is a little bit smaller than the multi-stream. Also, the spray radius also different. As you can see, the fixed 360 sprinkler is 0.7 into 0.9 spray radius, and for the multi-stream sprinkler you could reach to 0.8 into 1 meter spray radius. And the connection size also different. For the fixed sprinkler is 3 mm and multi-stream sprinkler is a little bit bigger, which is 4 mm. The fixed 360 sprinkler, for instance, has the ability to produce a very fine mist in 360 direction. This type of output are suitable for the fodder seed to grow on the early phase of growth. The 360 mist, however, are not an adjustable type. It is fixed to give out an output of just mist around 360 degree angle. The advantage on the other than it is suited for newly growing seed is that for the application of the sprinkler in the structure, it will only require 2 sprinkler per level, which indirectly decrease the cost of production. The actuator of the multi-stream sprinkler has the ability to control the spray radius in accordance to certain conditions required by the user. The bold advantage of this type of sprinkler is that it can be set up to not only misting but also can be adjusted to drip water. Water dripping is essential for fodder with an already grown leaf. A fodder with an already grown leaf requires more water to be absorbed by the root instead of the leaf. The main difference being that a fixed 360 sprinkler only works best for seed. However, the multi-stream sprinkler can itself throughout every phase of the plant growth. Conclusion and recommendation. Finally, the development of water pump system is to circulate water for fodder with NodeMCU was accomplished. As a result, using the NodeMCU as a microcontroller to manage the system automatically makes it easier for the user to keep track of their crops. NodeMCU features such as built-in Wi-Fi make it convenient for the user and especially for those who are pressed for time. This one is the recommendation for the project. First one is adding a nutrient mixture into the reservoir tank to increase the quality and growing rate of the fodder. Next one is using a GSM module to allow the user remote control feature and adding a notification system to alert the user of the status. The last one is adding a filtration system to the water pump to increase the quality of the water and to keep the pump from breaking. That's all from me. Thank you.